Happy New Year and welcome to WasmAssembly episode number 10. Today I have David Mytton on from Arcjet. Welcome, David.
Hi, thanks for having me.
It's a pleasure. So I end each episode with an invitation to let me know if you want to be on the show. And that's not just for the good looks. I actually do invite people when they raise their hand. You, David, were one of them. You wrote me a very nice email in which you said, and I quote, "I enjoyed the podcast episode with Steve Manuel from Extism. I know Steve, and I think Extism is a really interesting project, but I'm not sure about his comments on the component model." Well, when we recorded that episode, and we obviously linked to it in the show notes, I already felt that some of Steve's takes were maybe a little hot. And so I very friendly provoked him with some really hard questions, and we had a great time. And I informed Steve before this episode that we will have someone come on and react to his takes. So this is why today I have Steve on, who, as you have heard, had some comments on Steve's remarks. And this is where we are with David. And in your email, you further wrote, "At Arcjet, we're using Wit and the tools from the Bytecode Alliance like JCO to develop using the component model with no problems." And before we go into the nitty-gritty details of all of this, let me just first properly introduce you, David. So, David, you're the CEO of Arcjet, which is a software startup that helps developers protect their apps. You're also the co-founder of Console, which is a DevTools newsletter, which helps developers find the best tools. And you're an angel investor in early-stage developer first startups, and you're also working towards an engineering of science degree, a PhD actually, in sustainable computing at the University of Oxford. So that's quite the resume there. But today we mostly want to talk about Arcjet and its use of WebAssembly. But before we dive in, I just want to very quickly give a shout out to your own Console DevTools podcast, where you recently hosted an episode with Matt Butcher, CEO of Fermion. So if you're listening to this, if you're watching to this episode, definitely also listen to David's own episode and own podcast, subscribe to it. Before we actually talk about how Arcjet works, let me actually just first discuss what actually Arcjet does. So the punchline is security doesn't have to be a pain, and the listed features are bot detection, rate limiting, email validation, attack protection, data redaction. You call it a developer-first approach to security. So, David, could you just introduce yourself and Arcjet a little more, and just give us an overview of all the features that Arcjet has and what you do, and maybe just some background, how you started the company, how you got there.
Well, Arcjet is what we call security as code, and the idea is that it helps developers implement protections against common attacks like spam bots, fraudulent signups, general web application attacks. But you can do it in just a couple of lines of code and then get on with whatever else you've got to do to run your business. But then when you need to change the implementation, become more sophisticated, you've got access because it's in your code. And commonly, developers will solve this by throwing a firewall or a CDN in front of their application. And those are interesting products, but the challenge is it's just not in code. So you can't test it locally, and you can't change the rules dynamically and then look at the signals and maybe change your application response based on knowing where a user's from or re-authenticating because there was a suspicious request or something like that. And so Arcjet is an SDK currently just for JavaScript, but this year we'll be expanding into other tech stacks that makes it really easy to implement those features. And the SDK is the interesting bit that I think we're going to talk about because it includes a WebAssembly bundle where a lot of the analysis happens locally in your environment.
Nice. So is there any connection at all to your PhD? So sustainable computing, people have brought forward WebAssembly as like a pretty sustainable and pretty energy-friendly way of running code cross-platform specifically. Is there any connection, or is this just coincidence?
It's just a coincidence, unfortunately. I started the PhD before starting Arcjet and was running the console.dev newsletter, really just playing around with DevTools all day, every day. And a couple of years ago, I was thinking through, having sold my last company, how could I contribute back and figure out what are the major challenges we're facing. I thought climate change was an important one. And at the time, there was very little happening in the crossover between cloud computing and software engineering and the energy science side of dealing with sustainability, and in particular, sustainable computing. Often means data centers and energy, the carbon intensity of the grid, and how energy intensive programming languages, computers, data centers, all those systems are. And the goal really was that we should be able to continue using more and more and more compute, but having less and less and less impact on the environment, which is a really interesting challenge. And I wanted to be able to contribute my kind of 10, 15 years of experience in software engineering and cloud computing, bootstrap my knowledge of the energy science side of things by doing a science degree and try and contribute there.
Understood. Very interesting. I did a PhD as well after my master's degree, but not immediately after, but like on the job, which was a very interesting experience. Almost, yeah. Sometimes you get an overlap, sometimes you don't. So I was just curious how you managed to do that. So let's talk about Arcjet a little more. So there's an example app where people can just see Arcjet features applied to a Next.js project. You mentioned it's right now running on the JavaScript stack. So you support Bun, Dino, Nest.js, Node.js, Remix, SvelteKit, so everything JavaScript or TypeScript based. But then in the documentation, you say Django, which is, I think, Python, Ruby on Rails, which is obviously Ruby, and Laravel, which is PHP, are coming soon. And I guess this is where WebAssembly then comes in. So you wrote a bunch of WebAssembly blog posts where you mentioned all the exact details, but can you just elaborate a bit and give us the, let's say, 10,000 feet overview of how Arcjet uses WebAssembly, and maybe just mention some of those features again, give us some background on what people should expect when you say things like bot detection, for example. So what kind of bots do you detect? How does WebAssembly come into play there?
The classic way you solve this is by having an agent that runs on a server to do server-side security analysis, and then using a network firewall, and often that's a CDN in front of your application. And these are interesting architectures. It's kind of multi-layers. The problem is that both of those break when you deploy to modern serverless platforms. Developers over the last few years have had a real amazing time at all the new platforms that make it very easy just to push to Git, and then within a minute or two, you've got your application deployed globally. Those platforms include a network layer, and often they already have a CDN, so they distribute your assets and often the serverless functions as well globally. And there's nowhere to install an agent because most of the time you don't get access to the underlying compute. Maybe in the container, but really you don't want to be running an agent inside multiple containers. So the traditional way of protecting your application no longer works. And layering a CDN in front of another CDN just causes all sorts of problems with the network routing and being able to debug and performance. And so when I was playing around with this and spotted it as a potential problem when I was just writing the console newsletter, I was also thinking about, well, what new technologies are there today that would enable a different approach? And I'd been following WebAssembly for a while. I have seen what Steve was doing with Extism, and also a few other startups and projects doing really interesting things. And WebAssembly gives you some amazing properties that are perfect for security, notably the sandbox. So you have this very secure container, which is particularly useful when you want to analyze arbitrary web requests. And then also native or near native performance, which is again really important. One of the challenges with a WAF or other kind of security products is they just add latency and overhead to your application. And so being able to do parsing and other compute intensive activities with native performance is really important. So with that kind of concept in mind, the way that Arcjet works is you have the SDK, it's npm install Arcjet, and then we have adapters for different frameworks like Next.js, and it becomes a dependency in your application, single dependency. And then it integrates either the middleware layer or on individual API routes where you might want a bit more control. And that allows us to be very close to your application, but without interfering with your code, because that's really important. We don't want to change your environment in any way that changes how your code operates, but we want to make sure we can intercept every single request and analyze it. And so you call Arcjet, it's an SDK, you just import it into your code, and then you give it the rules that you want. So you could set up bot detection, say you want Google to index your website, but you want to block AI bots, then you can set up a rule just like that in your code. Because it's code, you can dynamically change it. So if you know a particular user is logged in or someone is coming from a particular country, you could change the rules at runtime. The call then passes that request into WebAssembly module, and that's running locally in your environment. And we can do quite a lot of analysis locally to detect certain attacks, do analysis on the request to pick up certain characteristics, do analysis on email addresses, for instance. And then depending on the rules that you have configured, it communicates with our service, which runs very close to your application, like in the same region, the same cloud region. And there we run WebAssembly again. Actually, we run the exact same code. We just run it in our Go API, so we can do a different analysis where we can do more things that might not be available on your server, like making network calls to look up MX records against a particular email that was submitted. And then you get the response back. And we try and do all of this analysis within 20 to 30 milliseconds so that we can pass all of the rules you configure, do this analysis, and then give you the response back. And then with that response object, you can change the how your application runs. So you just block a user, for instance, return a 403, or you could log something in your database, log something against that user session, change the logic depending on what your application does. And WebAssembly just allows us to do quite a lot of this locally. And then where we can't do certain things, we can run that exact same code in our servers, in our platform, and make sure that the same things are happening, but with augmented data that we can do on our side.
So some of these things, like, for example, email validation, that's something that people can do client-side, essentially, through a regular expression. But then I guess at some point you want to do a little more than just checking if it's a valid email address. You want to check, I don't know, has this been historically been on a whatever spamming list, for example, or is this maybe some sort of, I don't know, masked email address that people use, and you want to block this and not allow it, but at the same time not reveal that you operate with such a block list, so you want to have it on the server. Is there anything that runs on the client as well in your Arcjet environment? Or is it all on the server?
So it's currently all on the server. I think in the future, we want to connect into the client to take client signals, because those are very relevant, particularly bot detection. You can get a lot of signals from the browser. And I suppose that's where WebAssembly has traditionally come from. It's running native code within the browser. But I think that WebAssembly runs server-side is far more interesting, and you can do loads more things on the server side because of that context that you have. And this works perfectly in serverless environments. It's very similar if you have a server, it works just the same, but it means you don't have to manage the agent, and you can be a lot closer to your application to bring in the relevant context. But for now, it's all server-side.
So you mentioned serverless. I think in some of your blog posts, you mentioned some of the restrictions that you ran into, which meant you had to change certain things that you had started with, and then you had to change the architecture a little bit. Can you just outline some of the serverless constraints that you ran into that made running WebAssembly hard?
So when you're building WebAssembly, there are the WebAssembly components. There are options that you can provide to pre-initialize and optimize the output. Pre-initializing means that you're starting up the WebAssembly component, you're instantiating it, doing any parsing, and then it's loaded into memory. That startup time has a cold start time. And so what we can do as part of the build process is start it up on our side and then snapshot the memory and write that into the component, so that when it's loaded in the serverless environment, it's already done all of that initial work. And so we can speed up the startup time. But the trade-off there is a larger file size. Now, when we run our own code on our servers, the file size isn't that important because we start up our server and we just read the file off disk. But when we're distributing, say, an NPM package to a serverless function on one of the more popular platforms, depending on your pricing plan, they limit the maximum file size. And so we have this challenge of trying to balance performance, which is important, particularly in serverless runtimes where there could be a cold start if you don't have that many requests. But also we have these restrictions on the environment of the maximum file size that we can bundle in. And obviously reading files from disk has a performance impact as well. And so we tweak the settings on the WASM optimization tooling that we use, like Wiser, to, depending on the environment, we provide different settings to see what we can do with the optimization there.
Is there for each of the serverless providers some special tweak, or did you find the magic formula that works universally?
It depends, because the pricing plan in some cases will just determine what limits you have. So we try and minimize the file size, but I'm sure we'll talk about that. We work in Rust. We compile to WebAssembly from Rust, and so sometimes we're bringing in some of the Rust libraries and dependencies. One of the things that we have been doing recently is looking at the regular expression components, and building the full regular expression parsing engine can increase the size on disk quite significantly. And so we've been doing a lot of optimizations there to try and reduce our usage of that, and also to split up the components into different parts and only load them when we know we're going to use a certain rule.
So one of your blog posts also mentions that you switched from wasm-bindgen to Jco. So Jco, for background, a JavaScript toolchain for working with WebAssembly components. And wasm-bindgen, essentially sort of the same, but from a different background. So I think wasm-bindgen came from the Rust community, and the Jco tool is from the Bytecode Alliance. So what triggered the switch? Can you give us some more background there?
When I originally prototyped Arcjet, I wrote two bindings, or two SDKs. I wrote the JavaScript one, and I also wrote the Python one. And the JavaScript one was where we started. It's the most popular web language, so that's where we wanted to begin. But investing in WebAssembly, I wanted to make sure that we could go to other languages and other ecosystems with a bit of extra effort. So I wanted to make sure that it would work in Python as well. And so coming from Rust, I picked the tooling that was native to Rust, which is wasm-bindgen. And so that was where the original prototype was. We then continued to evaluate the product and build it out, hired some more people who know a lot more about WebAssembly and Rust than I do, and more in the community. And in particular, Jco has come out of the Bytecode Alliance as more or less a successor to wasm-bindgen, because most of the original maintainers of wasm-bindgen have moved into the component model, and they're working on it through the Bytecode Alliance. One of the fundamental things that we wanted to do was to have this cross-platform capability, because JavaScript is just the start. And so we wanted to move to a tool chain that would allow us to focus just on the WIT file, and then use the official tools so that we could generate bindings for the host language, because we don't want to have to create our own version of wasm-bindgen for every single language that we support. And we were betting on the Bytecode Alliance continuing to build out the tooling for different languages. So, for example, there's tooling there for Python, .NET, Ruby, and Go now, and that's expanded quite a bit from when I originally looked at it 2 or 3 years ago. And so we've made this bet that the ecosystem will continue to move, and we wanted to make a bet on the standardized approach to that, which in the case of JavaScript is using Jco, but really betting on WIT as the key interchange definition format.
So one of the future platforms that you mentioned is Laravel, which is PHP. What is the WIT situation there, and the support situation?
So this is where it starts to get more challenging, is where there are environments that don't have official support yet. But if we go back 2 years, just before I started the company, it was very similar. It was really just Rust, JavaScript, and Python, and the other ecosystems were under discussion. And so this is a bet that The Bytecode Alliance are going to continue to push support for these languages, and they've talked about it. We can either use their official tooling, but for instance, we run our own WebAssembly in Go on the server, and whilst there is official tooling from the Bytecode Alliance there, we actually use Wazero, which is an independent third-party runtime that is pure Go rather than depending on the CGO. And so we've been able to use that. And so we're betting that there will be a community PHP system that we can use, either from the Bytecode Alliance, or if we get to the point where we're working on it and we really need something, then we can develop it and we can contribute that back.
So talking about Jco real quick. So when you go to the Jco example page, they introduce both the Jco and ComponentizeJS. So ComponentizeJS provides a Mozilla SpiderMonkey embedding that then takes as an input a JavaScript source file and a WebAssembly bit component world, and then outputs a WebAssembly component binary with the same interface. But you don't actually directly use ComponentizeJS, even if the Jco, as I said, Hello World example even mentions it as like, it sounds like it seems something that they consider essential, but you get along without. You actually even opened a GitHub issue with the Bytecode Alliance telling them, hey, maybe you should not actually bundle ComponentizeJS with Jco. So what's the situation there?
So ComponentizeJS assumes that you're writing your code in JavaScript, you've got a WIT file, and then you want to generate WebAssembly from that. We are actually generating our WebAssembly from Rust. We're using Jco to pass the WIT file and generate the JS bindings, but it's just a coincidence that ComponentizeJS is bundled with Jco. And that's why we thought it should be optional. We're using Jco as a recommended toolset. We're not using ComponentizeJS, and it's optional. And so we thought this should just be an optional dependency. This is just part of our reluctance to add dependencies to our project because it just adds additional things that you've got to think about, supply chain risk. And so we thought that they should consider making it optional or splitting it out so that when you need it, you can bring it in, but when you don't need it, you don't have to use it. So the way that we do our code generation and building the WebAssembly, everything's just standard open source tooling. So we write the majority of our security code in Rust. It's just pure Rust. It's a crate. You would see it normally as if you looked at it as a Rust programmer, it looks like pure Rust. And then there's a small part of it, which is the interface between the WIT interface that we define and then whatever the host language is. And it exposes those Rust primitives to the WebAssembly boundary, and it does the translation between them. So we have whichever format we're using. Some people use JSON, some people use protobuf. This is where one of the challenges of going between languages, but it does that translation. But we're essentially using the Rust tooling Cargo to build the WebAssembly. We talked a little bit about the optimizations we do using Wiser and wasm there. And then we're using something like Jco or the other tooling to generate the bindings for the host language. And that's why we asked them to remove ComponentizeJS, because it's an optional extra and we're not using it. And it's probably similar to how other people are doing things.
Yeah, makes sense. So just for background, the Jco example is using JavaScript for implementing something like Cowsay as a JavaScript program. So it makes sense for them to use ComponentizeJS there. But yeah, given your background, obviously, it sounds like this is not so much something that makes sense. So a lot of the Arcjet code is open source, and I messed around the repo, looked what I can find and understand how things work. I failed to find actual bit files. So I guess this must be part of the proprietary. That's a hard word to say. Proprietary part of the code base. Can I talk about your bit usage a little more? Like how do you make the connection there? Why are your bit files proprietary and not public? Is this to protect your interfaces? Like why did you make that choice?
Right, and this is where we're coming at it from a different angle from the original idea behind WebAssembly. So it makes a lot of sense that you would want to write your code in JavaScript and then just have it implemented in WebAssembly and take advantage of the sandbox or the performance and then call it from JavaScript. That makes ComponentizeJS a really good tool for that. But our approach is almost the opposite. We're on the server and we're using WebAssembly as a secure sandbox to execute our code in your environment. Now, the way that we approach open source is that our JavaScript SDK that you integrate into your product is open source, and it's a standard open source license. It's what you would expect. But we're building a paid product, and our approach internally and my philosophy on open source is that we want to release the tooling that we use and that we're maintaining because we're using it, and then we contribute to the projects that we're using rather than the core product itself being open source. But we haven't made a decision yet on whether the WebAssembly bit should be open source, because there's an argument to say it should be because it's in the SDK and it's running in your environment. But there's no real reason why anyone would want to be able to make any changes to that and to have access to it. And so open sourcing it, I don't necessarily see the reason yet. That said, you can actually use the output that we have in the JavaScript repository. You can see the Jcode command that we use. That's in our package file, so you can see how we're building it from the WIT file. And then if you use WASM tools, then you can actually reverse engineer the WIT from the WebAssembly component. So it's kind of if you're willing to put the effort in, then you can get our WIT. And we just haven't taken a decision yet on making it open source because it's not been a blocker. It's just the decision hasn't been made yet.
Yeah, I guess this makes a lot of sense, especially when you are building a paid product. As I said, you're contributing back by, for example, if you implemented make the PHP tooling that you might want to add in the future for the Laravel environment back to open source. So I think that's a very fair choice. And I was just curious, poking around in the repo, so I didn't see any WIT there. In your email that you sent, you mentioned you were using WIT successfully, so that's why I started looking. Which brings us then back to the Steve Manuel Extism tool, which sort of promises a similar approach that you have taken just using the standards route. And it seems like you have been very successful with it. Did you ever look at Extism? Did you try it? If you did, why did you choose to not go that route, but instead follow the standards path? Can you just give us some more background on like your disagreement, and all in a very friendly way, obviously, with the Extism approach versus the standards approach?
I looked at Extism before I started Arcjet when I was doing the original prototype, and it didn't fit into our use case. And I really see it as kind of a third interesting use case that is somewhat out of the mainstream. So you've got WebAssembly being used in a web browser on the client side, which is where it started. And you've got WebAssembly being used on the server, which is where a lot of these Bytecode Alliance tools and runtimes are coming in. And we very clearly fit into that second model. Where Extism comes in is kind of a cross between those. It's this idea of having plugins, whereas part of your own product, you can allow your customers to extend it or write arbitrary code. And WebAssembly is the perfect place to do that because it's secure, it's performant, it will run in any environment. You can just let your customers get on with things. And I think it's a really cool product. If that's what we wanted to do, I would be using Extism. And also their newer project, XTP, which tries to get a lot closer to what the WebAssembly component model is doing. XTP didn't exist when I was looking at it, or it wasn't public, so I wasn't able to use it. And looking at Extism, you have to install their runtime SDK. And it's very similar to what we have to do with wasm or with Wazero or any of the runtimes. And as part of that process, you have to, or it will install a pre-built shared object, which allows them to run the WebAssembly. But that's an object that we don't control. It's developed by a third party. It's not part of a large open source organization with processes that we could contribute to. And it just felt like it wasn't in our best interest to build our product on the server side using this third party system built by an organization that we can get involved with. And so just working with the Bytecode Alliance processes that we're not a member. We contribute a little bit with pull requests or issues and things, but we felt that a lot more comfortable working with something like, it's almost like the Linux Foundation and how they run things. They are slightly separate from it, but we think applying standards and using standards is a better way to develop the ecosystem. And so whilst I agree with some of the issues that Steve raises, there's a lot of concerns around how Rust-centric the Bytecode Alliance is and what that means for how they design things, which we agree with. Felt it's a shame to advocate against open standards in many ways, and that was kind of my response to the episode. Is there are ways to do things, the context is important. What Extism is doing is a very particular problem set, which is quite different from what WebAssembly was originally designed for, but is great at solving. And I feel like they can coexist rather than being at odds with each other.
So you mentioned the Bytecode Alliance to be Rust focused maybe a little bit. You yourself are using Go, so that's already like a proof, if you will, that the standards can work. Maybe one final question on that. So you mentioned in the beginning when I asked, yeah, you might want to expand to the client as well in the future. So could Extism, something like Extism, have a place there, or do you think the Jco approach, which also can run in the client, despite some size challenges and so on, we talked about this in a different episode, where some optimization potential was still mentioned as being unexplored. Do you think something like Extism that has been used and practiced by a lot of people on the client as well could play a role there, or like what is your opinion there?
So our position is that we're all in on the Bytecode Alliance tooling. We're already using a lot of it, and so we will use that first when we go to another ecosystem. The challenges with that are very obvious when you go across languages. Like you said, we're using Go on the server. We write the code in Rust, and there are things missing, or just they don't match up exactly. One of the internal debates we had was around the result type and the option type, which exists in Rust and is one of the best features, in my opinion, for handling errors and dealing with the result of an execution. And that just doesn't exist in Go. And so when you represent that in the WIT format, you've then got to figure out, well, how do we create the bindings in Go that feel idiomatic to Go developers whilst having this completely incompatible type? And I think the Extism project have solved that in a really nice way, and how you translate between the host and the guest and what you're writing in. They've done an amazing job there. So I have nothing against Extism, and I think it would, if you were starting from scratch, you should evaluate both options. We've decided to go with the Bytecode Alliance toolset just because it is a progressing organization and means that we can rely on them, and if we need to, contribute back, rather than relying on a different organization that doesn't follow that structure. But I don't see any reason why you wouldn't want to consider that. I think my concern is just when you're advocating against open standards and the open way of doing things as the wrong way to do things, rather than this is just an alternative and this is why we think we're better, rather than this approach is not very good.
So you mentioned you are not a member of the Bytecode Alliance, but there are practitioners in the Bytecode Alliance, so it's not all ivory tower or something. Have you ever considered becoming a member?
Yeah, we're a small team. We're 5 people at the moment, so we just haven't gotten around to figuring out what our contribution should be. We're a member of the Linux Foundation and the CNCF, so we've started there. They run the WebAssembly conference, and we've submitted talks to that, so that's where we started. But joining the Bytecode Alliance, anyone can do it. It's not that expensive as a company, and individuals can join. They have elections, and you can participate in that process. It's just that we haven't decided to join yet.
Makes sense. Cool. So I guess this brings us slowly to the final part of the podcast, which is always WebAssembly, but not, WASM, but not. So David, when you instantiate streaming on any of your streaming devices, what is it that you currently watch or listen to?
So I've been watching The Silo recently, and Series 1 finished a while ago, and now Series 2 started, which is good. It's often something I'm watching when I'm flying. But to be honest, I spend more time reading, and I've just been going through the Mistborn series from Brandon Sanderson, which is a fantasy series. I'm really into fantasy and sci-fi, so I spend more time reading than streaming.
Hmm. I think someone else, I don't recall who, but someone who was a guest recently also mentioned Silo. So what is it that's interesting about that show?
Certainly the first series, it's unlike anything that I've seen before in terms of the size of the environment that the characters are existing in and all the little intricacies, and you just really don't know what's going on. It's very futuristic, and there's a lot of mystery behind it, and then you've got the internal politics. So there's just a lot of fun angles. I think series 2 has a lot to live up to, but certainly series 1 has been great.
Cool. And then the final question, if there's something that you could local get, as in something that you do, that you could then global set, as in something that you wish everyone else did, what would it be? And if you want, you can reverse the question. So something that you global get and then local set.
So I would local and global unset dependencies. This is something that I was doing over the holidays and working a lot in the JavaScript ecosystem. I've become very frustrated at the churn in dependencies, how often things are updated and how often things have breaking changes. And it became incredibly frustrating, the maintenance burden of maintaining or using a lot of the JavaScript frameworks. And so over the holidays, I rebuilt the console.dev website using just the Go standard library plus Tailwind CSS for the styling. And it was really fun because Go actually has everything you need built in. You might have to do a little bit of extra work on some things, like we use Notion as our CMS. And so creating an API client for that required a bit of extra work, but you can build a web server. I was able to create an in-memory cache and then build the website and have it running locally and building within, it was something like 0.5 milliseconds to build the entire thing and run versus the JavaScript framework that we're using, which would take 10 seconds to render just the home page. And I'm sure we could make optimizations there, but it was a fun project over the holidays to rebuild it using just the Go standard library. And I bet that if I come back in 10 years, it will still run in the exact same way. I can't say the same for JavaScript.
Yeah, so you were cheating a bit because you said you wanted to global unset. So I'm cheating a bit and say, actually, my questions were finished already, but the last but not typically marks the end of the show. But because it's a nice segue, you mentioned all those JavaScript frameworks that do have, I guess, dependency how like Next.js and SvelteKit and Dino and Bun and all those runtimes and just libraries that constantly evolve. So how do you deal with this as a yeah, provider of software that runs in between of all of those? Is this a problem at all?
It is a problem, and our goal, we haven't quite reached it yet, but our goal is to have zero dependencies in our JavaScript SDK. So when you install Arcjet, you are only trusting us, and nothing else is added into your dependency tree. We're not quite there. We've got a couple of dependencies that we're still using, but we're gradually removing them. And when it comes to the API, we're using proper semantic versioning. So at the moment, we're in .alpha. We're just about to go to beta. And when we go to beta, we are going to treat that as the stable API. And our goal is to never have a breaking change, just like Go. It may be impossible. We've done it once over the last 2 years, and we provided migrations to all of our users and helped them change. It was a very simple change. We're a startup, so we're still developing the API. But once we hit that 1.0 stable, we want to say to developers, you can continue using this for a very long time. We'll provide security updates, and we won't break compatibility. And we're going to try our very best to do that, just because it's so annoying as a developer to constantly have to fix breaking changes.
I can very much subscribe to this. So globally unsetting dependencies by going dependency less. In some cases, it can be the solution, I guess. So on your homepage, you mentioned on your blog, you mentioned you don't use social networks much. So while you have a LinkedIn, you probably don't answer it. But if there's people who want to follow your work, who want to reach out, if they have questions, if they want to learn more, how should they contact you?
So for Arcjet specifically, the Arcjet blog, we write a lot about how we're using WebAssembly and Go and Rust. So that's blog.arcjet.com, and it's available as an RSS feed. And also my personal blog, davidmytton.blog. I don't write as much as I used to. That's mostly sustainable computing related posts. Also has an RSS feed if you don't want loads of emails. And then just to reach me, it's david@arcjet.com.
Nice. And for people listening to this without looking at the show notes, it's Mytton with a Y. So I was initially asking David, how do you pronounce your name right? So it's Mytton, but it's written with a Y. So yeah, thank you very much, David. It was great having you on the show. And yeah, this was the proof. If you want to be on the show, just reach out. You know how to reach me. Tomayak everywhere except X, I guess. I'm almost leaving the platform now. But yeah, thank you very much for listening, and David, for being on the show. And I see you and watch you next time.
Thanks.
Bye-bye.